All right, I know what you're thinking. Oh, we're doing graphing. But this whole chapter we're doing graphing, so it's going to be great. And we are going to be graphing parabolas the whole chapter. And we're going to take it section by section and look at how these graphs change and are affected by parts of the equation. So today in 8.1, we're just getting started. And we are going to start with looking at the graph y equals x squared. So if you see down here, the first one we're going to graph is y equals x squared. Notice too, instead of y, it's f of x. And that's that good old function notation we get away from sometimes, but it's just that special notation that means that it's a function in terms of x, it's in place of the y. And, if we wanted to write things like, f of 0 equals 0, like when I plug in 0 for x, it equals 0. And that's one way we can write that. So what we are going to do is we're going to make our chart here. Make a chart for each of these. And for this one, when x is 0, y is 0. When x is 1, 1 times 1 is 1. When x is negative 1, negative times 1, or negative 1 times negative 1 is 1. When x is 2, 2 times 2 is 4. When x is negative 2 times negative 2 is 4. And 3 is 9, negative 3 is 9. So we're going to graph those up here. And this is going to be what we call our parent function, the one that all the other ones relate to. So 0, 0, 1, 2 is 4, 3 is 9, and we get a really nice parabola like that. Okay, so this is our y equals x squared, and that is our parent function that we're going to just keep referring back to. Trying to move there we go. All right, so now for our next one, I'm going to use blue for my g of x, and we are going to do the same thing and plot some points. So for this one, when x is 0, 3 times 0 is still 0. When x is 1, 3 times 1 squared is 3 times 1 or 3. Same thing for negative 1. When x is 2, 3 times 2 squared is 4, and we get 12. And negative 2 is the same thing, 12. I'm going to stop there because 12 is a pretty big number. So here it's still at 0, but now at 1 it's 3, and at 2 it's 12. So I'm going to draw this parabola here, and we can see how it relates to our parent function. So I think we can see it has the same vertex, but it is more narrow, right? It is more narrow than the original. Our next one we'll do, let's do this red color. So for this one, we're going to make a chart as well. 0 is still 0. Now 1 half times 1 is 1 half. So negative 1 is also 1 half. Now when we do 2 times 1 half of 2 times 2, which is, 4. Let's try that again. 1 half of 4 is 2, so negative 2 is going to be the same. I'm going to jump up to 4 here, just because I know I'm going to divide by 2, so I want a nice even number. So 1 half of 4 times 4, which is 16, is going to be 8. So negative 4 is also 8. So let's see. 0, 0. 1 is 1 half. We'll plot that. 2 is 2. And then 4 was 8. And so here is my red parabola. And now, how does this one compare to the black parabola, the parent function? This is wider. I think you would agree. It is wider with the same vertex. And finally, let's do this one maybe in this yellow gold color. And we're going to plug in 0 is still 0. 1. Negative 2 times 1 is negative 2. So negative 1, same thing. Negative 2 times 4 is negative 8. And for negative 2, it will be the same. So let's plot those. Let's see, we have 0, 0 still. 1 is negative 2. 2 is negative 8. So for this one, we can see even by looking at above at the black one, it is more narrow, and it also is flipped, or we could say reflected over the x-axis there. It's flipped down, right? And so what do we observe about these graphs? Well, when we look at our graphs and we look at the equations, notice when we had this 3 here and that 2, it was more narrow. And so if a, right, our number in front of the x squared, is greater than 1, so to speak, the graph is more narrow. But now with the red graph, it was wider. And notice there, our term in front of the x squared was a fraction. So for my second observation, if my a is a fraction less than 1, the graph is wider. Okay, so if we have a fraction in front of the x squared, it's going to be wider. And then finally, we observed that if a is negative, it is flipped or points down, right? It's going to point down then. And so those are some things to keep in mind. And so as you're graphing on your assignment today, you can make a little chart just like I did, but you're going to comment on each one just like we did here, how it relates to y equals x squared. Is it more narrow? Is it wider? Is it flipped? Is it narrow and flipped, like our last example? So I want you to note how the coefficient, the number in front of the x squared, affects the graph.